Hi, now we are going to see about a Queen-McCluskey or the tabulation method used for a Boolean expression minimization. So already a two method is discussed about the Boolean expression minimization. The first one is using Boolean theorems and laws. We can minimize that Boolean theorems and laws. We can minimize the Boolean expression. And second method is using a K-map. So in this, what is the difficulty we have faced is that in a Boolean theorems and laws, we have to remember the laws and the theorems for the simplification. And in the K-map, it is very complex when the input variable is increases. When the input variable increases, as a K-map grouping is very complex. So that we are going for a tabulation method. So it is not. It is not a condition of complexity when the variable increases. So now we are going to see how it can be used to minimize the Boolean expression. The given problem, it is first we have to check it is a 4 variable. So you can cross check this final result with the K-map also, since it is a 4 variables. 4 variable K-map value is also uh, easy for finding out the result whether it is a correct or not in the tabulation method. So better we can do it using a 4 variable K-map and cross check your result in the tabulation method. So now comes, these are all the min terms given. So first express the min terms in terms of a binary. So it is a 4 variable, so represent this in a 4 variable. 0 in 4 variable, each and every min terms in a 4 variable representation. After that, we have to find out how many ones are there. So based on that, it is a index form. So here it is no one is present, so it is a 0 index. Here one is present, so it is a 1 index. Here it is 1 is present, so it is a 1 index. Here two ones are present, 2 index 2, and this is 3, and this is 1, and this is 2, and this is 2, and this is 3, and this is 4. So based on that, we are having an index. Now first step is that, as usual in the K-map, first we have to find which one is an what are all the prime implicants available, and second one, which one is an essential prime implicant. We have to uh, finally write in a Boolean expression. So first step is finding a all prime implicant. So here how to find a all prime implicants available here. So first we have to write this min terms given in form of indexes grouped grouped in the form of indexes. So here it is a index, so it is a 0 index, here index 1, and this is index 2, and this is index 3, and this is index 4. So under index 0 only a 0 min term is present. Index 1 means here we are having what are the index 1, this one, and these three are the index 1, that is here it is 1, here it is 2 min term 1, min term 2, and min term 8 are comes under index 1. So first we have to group this according to the value of index, and next one we have to check for the 1 bit change between the index min terms. That means between a 0 and 1 we have to check. Similarly between 1 and 2 we have to check. Between a second index and a third index, so each and every uh, min terms have to compare with the another index, that is 0 with 1 we have to check it. If there is a 1 bit change between this, means we have to consider this grouping. So here it is a 1 bit change. So how we are going to write means 0 0 0. Here it is a 1 bit change, so it is considered as a z dash. So that we will see in the next chart. Here it is a second list, so that is between these two we are having a 1 bit change, so we are considering it as a 0 comma 1, and it has 1 bit change, so it is represented as a dash. Similarly we have to check between 0 to 2 and 0 to 8. If there is a 1 bit change, so we have to mention it as a dash, and remaining values as such. And next comes, we have to check with 1 with 3, 1 with 5, 1 with 10, and 1 with 12. If there is a possibility of 1 bit change between those minterms, we have to represent, or else we can leave it. Next comes 2 with 3, right? 2 with 3, 2 with 5, 2 with 10, and 2 with 12, like that. Again we have to compare 3 with 7, 3 with 13, and 5 with, like that. If we consider and there is a 1 bit change, we have to represent a dash in that particular variable, and we have to represent a chart like this. Next thing, we have to check for third reduction. This is a first reduction, sorry, this is a first reduction, and second reduction is possible or not, we have to check. How to do that means, this dash should be common. So let us consider this minterm, that is reduction 0 1, and here we are having 0 0 1 dash. So in these two, dash is common. So first we have to consider dash is common here. Again we are having a 1 bit change between these, uh, 0 1 2 3. So we are going to write it as 0 comma 1 comma 2 comma 3, and it is a value, variable value is can be written as 0 0 dash dash. This is already present, and this is what a 1 bit change now. So how we are going to write means, like this we are going to write. This is a chart already given, and here second reduction is possible, means we have to go like this. So it is 0 1 0 1 2 3. Here it is 0 0 dash dash. So like that we have to check. And in the previous also we have to concentrate. If it is 0 and 1 is group, means just for our reference, just to put a tick mark on the side of 0 and 1. So whatever minterms is not covered here, it has to be written as a variable at last. So here, like that, for a second reduction we are matching with the minterms, so it is 0 and 1 is present. Similarly, if we compare this 0 2 with 1 0, there is also a value of 0 0 dash dash. So here comes, it is present inside the same 0 2 and 1 1 3. So this 2 we can write it as a single one. So just put a tick mark for 0 2 and 1 3, right? Like that we have to just put a tick mark. So here 0 8 sorry 8 12 and 12 13 will not available in any of the grouping. So we have to represent the value of this minterm. So it is a here it is C bar, here it is D bar. So A means 1 is present, dash means leave it, and here it is C bar, here it is D bar, since it is 0 is present. So we have to express in terms of a minterm variable. And next again we have to check for the groupings if the two dash is common. So these two is considered as a 1, and if there is a 2 dash is common in the same position, and again 1 bit change, means we are having a third reduction. So that is not possible here. So we are having, these are all the min terms. What it is, these two are common. Similarly, these two are common. These two are common. So we can write it as a only 4 minterms: A bar, D bar, B bar, D bar, A bar, D, and B, D. And these 3 minterms. So totally we are having a 6 prime implicants are available here. Among this, which is an essential one, we have to check. So essential prime implicant, to find the essential prime implicant, we have to know what is prime implicant, what are all the prime implicants. So that is prime implicant and a minterms. So in the vertical order we have to write a prime implicant, in the horizontal order we have to write the what are all the minterms given in the problem. So here it is A bar, B bar. So where we are getting A bar, B bar, means in A bar, B bar, what are all the minterms present? 0 1 2 3. 0 1 2 3 is present in A bar, B bar. So we can put a cross mark for minterms 0 1 2 and 3. So these are all the minterms like that. We have to put a cross mark, and this is now we have to check for the essential prime implicant. So in these six prime implicants, which one is essential? We have to consider for that. So which minterm comes under only one prime implicant? This minterm comes under only this prime implicant. So that is essential one, that is represented as a circle, represented by a circle. Similarly, this 15 comes under only this prime implicant. So BD and B bar D bar is an essential one. So B bar D bar is important and BD is also needed. Next, also we have to check all the minterms should be covered in it. So if we consider B bar D bar, it covers, if we consider this line, it covers 0, 2 and 8 and 10 is covered. If we consider this BD, we consider this BD, it covers 5, 7, 13 and 15 is covered. So what is remaining? Here it is a 1, here it is a 3 and 12 is remaining. So we have to consider any one prime implicant which covers this three minterms. So what we can consider, the if we consider a bar B bar means it covers these two prime implicants 1 and 3, and 12 is covered in any one of this. So we can consider any one of this minterm. So let it be a bar, sorry, a C bar D bar. So the answer is, this is what our essential prime implicant. At last we got it. Thank you.